In this video, I'm gonna talk about optimization in Calculus 1. Let's first look at some steps you need to do before you do the questions. First, we should read the question and understand what's given. I know this part, you might think, oh, I just read the question, but what I mean by that is we should know, well, what do we need to maximize or minimize what's given to us, and you should draw a picture if needed. The second step is you should introduce some variables. So what I usually say is you should translate English to math. For example, if the question says volume, maybe you want to use V. If the question says, well, let's find the price, then maybe you want to use P or cost, C, or something like that. And maybe you want to label some of the variables in your graph. Then you want to write whatever you need to maximize or minimize, let's call it Q, in terms of other variables. This formula may involve more than one variable. It may or may not depend on how you define your variables, and we'll see examples for both cases. If in step 3, the formula involves more than one variable, which is what most likely gonna happen, then you should use the given information to relate those variables together. So instead of just one equation or one formula for Q, you might have another equation for the other variables. So let's say x, y, or something like y equals to another function of x, relate them together, and then you want to isolate for one of the variable, plug it back into this equation, so that the formula for Q has only one variable, because in this course you only know how to take the derivative with one variable, right? And then you should always find the domain of the function, okay? Otherwise you might have multiple critical points and you don't know which one to use. You might get involved with problems like that. So you want to find the domain of the function, make sure whatever value you get, it actually makes sense in the application question. For example, you don't want to have negative distance, you don't want to have let's say negative prices or something like that. So lots of time your variable, the domain has to be bigger than 0 and might have to be smaller than some numbers. We'll see. And lastly, you use what you learned from before to find the absolute max or mean value of the function. So you might need to take the derivative, set it to 0, and figure out what it is, and use first derivative test or the second derivative test to figure out if this is your maximum or minimum you're looking for. Now let's look at one example. We're planning to make an open rectangular box from a 3 feet to 8 feet pieces of a cardboard. So once I read the first sentence, I know that I have two informations here. One is, I have 3 feet by 8 feet piece of cardboard. I know the width, I know the length. By cutting the congruent squares from the corners and folding up to the sides. So let's draw a graph. As I said, draw a graph might be helpful, so let's draw a graph. I have a 3 by 8 cardboard, so let's label it here. So this is my cardboard, and I need to cut congruent squares from the corners. So let's cut some squares. Okay, that's one square. Hopefully this is actually a square, but I'm just gonna call it a square. Paste. Okay, let's put another one here. And another one here. And another one here. Okay, and I'm gonna erase those highlight stuff. Alright, so that's my 4 congruent squares, and I'm gonna cut those and make open rectangular box. When I say open, that means no lid, okay? So this means no lid. Alright, so those are what's given to me. And now they ask you what are the dimensions of the square. So they're asking the dimensions of those. Okay, what are the dimensions of those to maximize? So this is a keyword, maximize. I want to maximize something. And let's see, what do I need to maximize? I need to maximize the volume of the box. Right, so well, my Q from before, that's gonna be my V. So let's call this V. Alright, so let's check what I did. I read the question. I understand what's given to me. I know that, well, this is given to me. And I understand I need to maximize the volume of the box. And I draw a picture. Okay, so now I need to introduce variables. So as I said, I'm just gonna call volume V. And the other thing I need to do is what dimension of the square. So let's call the side length of the square, let's call it x, for example. So now I introduce two variables. Not just that, right now I'm gonna do one more thing because I'm making a rectangular box, so I'm gonna draw a rectangular box as well. Okay, just to make sure you know what's going on, I'm gonna draw a box. Doesn't have to be perfect, just, well, as long as you can understand. Okay, it's clearly not perfect, but it's okay. Alright, so let's say this is my box. Okay, maybe I should erase something. Shall I? So let's say, ooh, that's bad. Never mind. Let me just draw a bad box then. Okay, I want to use dashed line for those behind. Okay, so now I want to label this one too, so I know how to calculate my volume. If I call this part x, then here should be x as well. Here should be x, here should be x, so those are all x, right? And now let's think about it. I'm gonna fold this part up, right? If you fold this part up, and you need to fold this part up as well, so you need to fold this part up, fold this part up, fold this part up as well. So that means the height of my box is gonna be x, right? Because why? Because this part is x. Okay, so the height of my box is x. Now let's look at this part. Okay, so once I fold it up, that's gonna be this part, right? That's gonna be this part and this part. So that's gonna be, so let's see, this part is what? In total, this is 8, this is x, this is x. So this part is gonna be 8 minus 2x, which is gonna be this. That's 8 minus 2x. Okay, we also have this part to figure out. That's gonna be this part, fold up, right? And the whole thing is 3. I cut it out 2x. So what's left in the middle is 3 minus 2x. Sorry, 2x. Okay, so that means, well, this part is 3 minus 2x. I know my graph doesn't look like what I claim them to be, because clearly they should not be so similar to each other, but it's okay. You know, as long as you understand the graph, it doesn't need to be accurate, right? So now I have all the info. I read the question, I understand, I introduced variable, I labeled them on graph, I have everything. Okay, so now you can start doing the question. So technically you should define your variables. So what I used x here, I should define it. I used v here, I should also define it. So let's define that first before we do anything. So let's say let x be the side length of the squares to be cut. Okay, and the other variable I used is volume, and let V be the volume of the box. Alright, so now we know that what my next step is. I need to write a function of what I need to maximize using my variable. Here we are lucky because by setup I only have one variable, which is x, so we're good. We're all good. Okay, so then we have volume. It's a function of x, which is gonna be with, let's say, 8 minus 2x times 3 minus 2x times x. Okay, so it's this length times this length times this length. And now of course you can expand it. So this, after expansion, you can get 4x cubed minus 22x squared plus 24x. Alright, so now if you go back, you'll see that, well, I finished 1, I finished 2, I finished 3, and I don't need to do 4 because, why? Because I only have one variable. I don't need to reduce it to one variable only because that's all I have. So now we need to do step 5, which was find the volume of the function. So to find, not volume, the domain of the function, what did I just say? The domain of the function. So if you only look at this, it seems like v, the function, is defined everywhere on real numbers. However, because we're doing real life application, we know that, well, it doesn't make sense to for us to have, for example, x is 0 doesn't make sense because if it's 0, you cannot fold and make a box anymore. So first of all, we want, so let's say domain, we want x to be bigger than 0. I use this because we have more than just one condition. Okay, so we don't want this to be 0. Other than that, we also don't want any of the dimension to be 0, right? Because it doesn't make sense. If they are 0, how do you make a box, right? So at the same time, I don't want 8 minus 2x to be 0 or smaller than 0. I also don't want 3 minus 2x to be negative or 0. Other than that, everything else seems fine, right? So let's figure it out. So the first one would still be x squared than 0. This one, let's simplify it a little bit. You have 8 is greater than 2x. Divide by 2 on both sides, which means, well, x is less than 4. Alright, so now I have two conditions. I have x is greater than 0, x is less than 4. Let's check the third condition. Again, move the 2x to the other side. We have 3 is greater than 2x, which means x has to be smaller than 3 over 2. Okay, so now I have 3 inequalities, and I need all of them to satisfy at the same time. Okay, they have to all satisfy at the same time. So some of you might be able to see that, well, that means I need to keep this one. Oops, I didn't mean to use this. That means I need to keep this one, and I need to keep this one. In case you are not very good at inequality, what you can do is you can always draw a real number line. So let's draw a real number line for those people who don't know how to determine. So I want x to be bigger than 0, so let's draw it here. Okay, x needs to be bigger than 0. It needs to be smaller than 4, so let's call this part 4. So it needs to be here as well. It also needs to be smaller than 3 over 2, so let's call this 3 over 2. And you can draw another one smaller than this. Okay, I said it has to satisfy all three, means that you pick the intersection parts, and you can see that the intersection part is here. Okay, which means my x has to be bigger than 0 and smaller than 2 over 3. Okay, so if you are not sure, you can always draw a real number line. If you can tell, you can directly say it. So my domain is going to be x is greater than 0, smaller than 3 over 2. Okay, so this is my domain. So let's highlight it in case you forget about it later. Okay, now I've finished step 5 as well. Now let's go look at step 6. We need to find the maximum or minimum of this function. So I have this function, so let's highlight it as well, because well, this is what I need, this function. So to find, the maximum or minimum, especially now we don't have a closed interval. You can see that this is an open interval, right? Open interval. If it has any max or minimum value, it must be at the critical point. So we need to find the critical point of this. So let's do that. Let's take the derivative. So I'm gonna move slightly, see if I have more space, slightly to the side because I don't have enough space. So v prime of x, take the derivative, that's gonna be 12x squared minus 44x plus 24, right? This exists within everywhere in its domain, so let's set it to 0. Alright, you can see that this is a quadratic formula. Alright, so we can factor things out. But before that, I think I'm gonna divide by 12 first, so it's easier for me because you can do that. So x squared minus 44 over 12x plus 2 equals to 0. Of course, you don't have to do that. You can just solve it directly, and thus I'm gonna cancel out. Let's simplify this. So 44 divided by 4 is 11. 12 divided by 4 is 3, so it's 11 over 3. And this is basically x minus 3 times x minus 3 over 2. I mean 2 over 3. My bad. Okay. If you don't know how to get from here to here, just use quadratic formula. Okay? Just use quadratic formula if needed. It's not a big deal. Alright? So now, maybe I should write it down in case someone didn't get what I said. From here to here, you can just use quadratic formula if you need. If needed. Okay, now let's continue, and we can see that for v prime of x to be 0, I need x to be 3 or x to be 2 over 3. So x is 3, or let's write it here, or x equals 2 over 3. However, we know that the domain is here. This is my domain. 3 is not in my domain, right? Which means we need to discard it. So let's remove this. Oops. Maybe I'll write it like this. So we don't want this. Why? Because it's not in the domain. is not in my domain, which is from 0 to 3 over 2. Okay, that means my critical point is only this. So let me highlight it again. So those are the key points. This is my critical point. Maybe I'll write it down as well in case you don't catch what I said. Alright, once we reach here, you have two choices. Okay, one is you can use the first derivative test. Two is you can use the second derivative test. It's really up to you which one you want to use. I'm gonna show you one. So let's say second derivative test here, and in the next question I'll use the first derivative test. Okay, so let's use the second derivative test, which I need to take the second derivative of v prime. Of v, so take derivative again. That's gonna be the second derivative of v. So let's take derivative. We have v prime x. It's gonna be 24x minus 44. Right, and I'm gonna plug in my critical point in this. So that means v prime of 2 over, yeah, that's correct, 2 over 3 is 24 times 2 over 3 minus 44. Okay, this will give me, so you can calculate it yourself. This is 8, so that's 16 minus 44. That's gonna be negative for sure, so negative 28, which is smaller than 0. So by second derivative test, if you don't recall what it is, or you don't remember it at all, you can think of it in this way. Well, because this is less than 0, which means the function concave down, right? Concave down at this point. Okay, if this is a critical point, it must be either minimum or maximum, and it's concave down, then it must be a maximum. Okay, if you don't want to remember, don't want to memorize, then just draw a graph and see. By second derivative test, we know that v reaches maximum when x equals to 3 over 2. Okay, and this is our absolute maximum because this is our only critical point, and we don't have any endpoint because this is open interval, right? So that means my dimension of my box, so you can also write it here. So this is absolute max, since we have a unique critical point. And no endpoint, have no space to write it. Hold on, let me move it out a little bit. Okay, whatever. And no endpoint. Okay, so that means my dimension should answer the question, because he asked you the dimension of the box. Not dimension of the box, what did he ask? Dimension of the square. Okay. Dimension of the square, which is x, right? Will be x is 2 over 3. So 2 over 3 times the centimeter. It's feet, okay. Change it to feet. Feet by 2 over 3 feet. Okay, so that's the end of this question. I'll see you in the next video.